Hey guys, today we have an interview with AJ, a software engineer from Microsoft. In this mock system design interview, we'll actually include the entire unfiltered process of figuring out the functional requirements, the high-level design, as well as a couple of deep dives. With that intro out of the way, let's get right into it.
Let's do this one. Design a coding platform that is
Got it. Okay. So just making sure that I understand what that means. Basically, I imagine the things that we're looking for is that, there's a platform that allows users to look through, a catalog of questions and go and select a question and then try and write their code and run it, in the browser, right? So a couple of questions I have for you on that is, kind of which parts of that we might want to focus on, and then similarly, which users we care about, right? So I imagine over here the main things that we care about is the actual, logged in user flow. We don't care about any of the admin processes, right? Like adding questions, things like that.
Yes, agreed.
Okay, admin actions. So, I know that, LeetCode has a bunch of search by, I don't believe it has text search, but it does have categories. Do we want to include any of that? Or maybe are we strictly focused on, you will have a question, you want to run it?
Yeah, so let's focus on just having a question and running it first.
Okay.
If we have time, we can think about search and tagging.
Question. It's running it. Okay, out of scope is, you said, search and problem list viewing. Okay, that makes sense to me. I guess similarly, do we care about any of the other, features like I know they run, I'm pretty sure they run competitions, right, on LeetCode.
Yeah. So let's do this. Let's focus on having a question and running it.
Mhm.
If we have time, in order, we can go for contests and leaderboards, and then after that, search and problem list.
Okay, so this is second prio, we'll say this is third prio, and then admin actions is just completely out of scope. Okay,
Yeah,
I think given, that, I want to translate this into a series of functional requirements, which is that, user should be able to view problem statement on page. User should be able to modify, edit their code live in an editor supporting multiple languages, and then user should be able to execute code in live sandbox against our existing test cases. Does that sound like we're on the same page for the functional requirements?
Yeah, I think so.
Okay. In that case, I'll go ahead and go into the non-functional requirements that we care about, which normally when we're talking about non-functional requirements, I usually think of these as, trade-offs you might be making related to cap theorem. But I think in this question, a big thing that we care about is actually sandboxed environments, right? Sandbox requirement environments for code execution. And that's relevant because we're, I think, realistically going to end up running these against our backend services, right? So let me actually think about that real quick. So one of the things we said is that we want to support any language, right? So the second you have that, I think you lose the possibility of running this on the client itself. So if this was solely JavaScript, I think there might be options for doing it solely in the client, but with our multiple languages support, I think, yeah, this will have to be our own environment. So sandboxing is definitely required. And then the other thing we, want to have is that edits are low latency. This one is maybe won't require us to do anything on our end because it'll all be client side anyways. And I don't see us needing any reason to sync, but maybe we do. And then the third thing might be that tests should execute less than 5 seconds, and where's the and key? And limited in total memory use. Yeah, does that sound okay?
Yeah, I think that mostly makes sense. Can you explain the edits or low latency part a bit more?
Yeah, so here I'm imagining, the user goes ahead and they type a bunch of stuff, right? One thing that I'm thinking is, this isn't clear to me yet, so I'm just including it in case it is relevant, is if we do any sort of client-server syncing, we might need that operation to be fast, right? In the sense that they make their edits, maybe they send off something, and then we have to, give some information back. But I'm kind of putting this as like a maybe. I don't think it'll actually be relevant because even if we do have client, server syncing, the latency doesn't. Yeah, I think I'll actually just leave this one out because the latency for the syncing doesn't really matter, right? All the edits they're going to do are just on their own machine.
Okay, and syncing kind of happens asynchronously.
Yeah, I'm going to actually put this in, client server syncing is out of scope, right? Because I was thinking of this because like if the client crashes or something, right? We don't need to actually persist in our backend services. We could probably just have like a local, index instead, right?
That makes sense to me. Sure.
Okay. Though I think LeetCode itself does do this client-server syncing because your answers seem to, persist forever. Okay, sure. If we're all on board for these things, then I'll go ahead into the entities and the APIs. So we have our user. I think we have a problem, right? We have, tests, which is part of a problem, but a bit separate. And then we have our sandbox, right? In a sense, which is the, I don't know if I should separate out the client from the sandbox. So maybe we can just say that the user is going to be closer to, this, right? The client. It's not the same thing. And let's think about the APIs that are involved. The main things we care about doing are, looking at a problem. So problem ID, which should return to us basically, problem. Here is a product statement. Yeah, a lot of the stuff is because we don't really have any client-server syncing. There is no real API for the editing part, right? It's more of just post, problems, problem ID, submit, right? Is kind of the user action where they're going to take, they're going to have their problem ID, and they're going to have their code, right? And this is going to be an auth request where it's going to be stored in the header. And I guess you have the language here, which is pretty important. And there might be some other data that we come back to, but I think these are the most relevant parts that we'll want to account for. Yeah, so given this, is it actually okay if I go ahead into the high-level design?
Yeah, please go ahead.
Actually, Okay, so kind of separate is that, you do have a post request for maybe, update language, right? But I think that's not the focus of the question. So I'll uh, just put a side note. Yeah, so let's say that we have our
Quick question. What does update language do here?
if they're coding in Python or JavaScript or uh, this is more something that uh, I was thinking would be a request, but in reality, it should just end up being a client-side interaction.
Okay.
Yep.
And one note, you don't have to get to it now, but I'd like to know how users can learn the results of their submission. Right?
How they can learn the results?
Like they submit a problem, they want to get back the results of their submission. Right?
Right. Yeah. So, given that this is going to be still 5 seconds, I imagine that this is the kind of thing that's returning results, right? So we kind of left that out in the entities, so we do still have that, right? If we had some system where it would take longer for results to be calculated, I think you would have to have a separate endpoint that you're listening to for the results. But because we already have this constraint that tests should execute under 5 seconds, I think it's reasonable to have this as the response of the post request, right? Because it'll be under 10. Does that make sense?
Right. Yeah. Okay. So we're getting the result async or synchronously. Basically.
Yeah, synchronously. Because I don't think our requirements basically don't force us into async, right? Yeah. So I know a lot of the times people like to do back of the envelope calculations at this point, but I think I'm going to defer that and just start with something simple to have all of our basic functional requirements out of the way. If that works for you.
Yeah, that's good.
Cool. Yeah, so let's go ahead and say we have our client, which is going to be the user on their browser. We'll have, some server that's running, and we have a couple of bits of data. We have our, problem DB, problems DB. What is this going to store? Realistically, this should have a table for, the problems, which is going to have like a problem ID, text, let's say, description. It's going to have tags, maybe. This could be, multiple tags, but I'll just, for simplicity, denote it like this, and then other metadata. The important thing to talk about here is how do we have a relationship between tests and problems themselves. I think here, you'd have a separate table which has a test ID, problem ID. It's going to have probably a language. And then I'm trying to think of what kind of tests you would actually store, right? I'm pretty sure you would want to store test cases, maybe some string that you're going to input, right, into whatever function you're trying to run. I think relevant thing to note here is that we would have a secondary index on the problem ID so that we could find all of the tests related to a problem efficiently, right? Yeah, so what this would look like, I think, if you were to draw out the labels is, all of the edits that a client has to do is going to be just maintained. And I believe there's some packages out there that let you run a code, execution environment on the client side really simply to handle all the things like formatting and and the highlighting for syntax and stuff like that. So I think we don't have to care about that stuff. I think it's called maybe it's called Monokai, but that sounds like the theme for me. Anyways, not that important. I think the bigger thing is, we'll have the client do a bunch of edits. They will go ahead and try to make a submission, and then we have to figure out what's going to happen here, right? Even before that, the submission part, we can kind of, we can kind of list out how you would, find all the information for a problem. That one's straightforward. You can just call problems here, and because we know what the problem ID is already, because the assumption is that we're on a problem page, this should be, relatively fast, right? Because LeetCode has maybe less than 5K problems. So this data here is tiny. Yeah, so the other thing we kind of want to cover is how do we run these tests, right? How do we execute the code that the user has written against the existing test cases? One default option you have is you can actually just run the test directly in memory on the server, but I think that's not great. But even if we did that, I think that no, okay, I was going to say that would fulfill our functional requirements, but because we're supporting multiple languages, that actually doesn't still. Does this all sound okay to you so far?
Yeah, I mean, the database makes sense. As far as running the code on the server, interested to see how you solve that problem.
Yeah, I don't think we'd want to do that at all, because one part, I already know we're not going to fulfill our non-functional requirements for that, but then a separate part is actually, that becomes almost even more complicated, because if you need to support multiple languages, you typically need separate environments on a per language basis, right? So we actually have a couple of options here that I can talk about. So if you want a complete sandbox environment that's temporary, one option you have is, every single time we need to run a test, you can actually call AWS Lambda to run that in a separate, Lambda instance. Let's talk about, what goes well there and what doesn't, right? So, I think back in the day for Lambdas, you had a cold start problem. Nowadays, that's no longer really true. You'd have like a 500 millisecond delay, but in any case, that's pretty tolerable for us, right? The second option that you kind of have if you need to run tests all the time is you can have a series of Docker containers, right? And for each of the languages that you need to support, you can actually have Docker containers that are set up to support or include all of the relevant packages that you need to run each of your operations. And let's talk about maybe the pros and cons, right? I feel like the option with the Docker containers is probably a bit simpler, and at the same time, it's going to cost less. So this does work as somewhat of an option, but then you don't really have as much isolation between the runs as you might otherwise, as you would with the AWS Lambda option. And because, we don't really have to care about cold starts, whether they exist now or they, we're making the assumption that it doesn't really exist that much anymore, which is somewhat true. But even if cold start was an issue, I think, we have enough buffer with our latency that Lambda fits in pretty well. So I'm going to kind of go for that, right? As in order to actually run our code in a sandbox environment, we're just going to use AWS Lambda to run each set of tests. So the important thing to talk about is then, what's actually going to be updated, right? Because we have our tests, we have an instance of a run. How are we, storing that and sending that back to the user, right? So one thing I actually didn't talk about in our original requirements is, if we're including run history, right? So that's my
Yeah.
my question.
Can we include that as like submission history for a given problem?
Right. Okay. So we're saying that users should be actually able to see run history.
Yeah,
Okay. Able to
I think
see.
that's a good idea.
Okay. So in that case, now we have more tables that we need to include, right? So originally, I kind of defaulted to running. I don't think I actually said what database we're going to use. Sorry, I'm trying to move this over and it's kind of stuck. There we go.
Actually, could you just explain what changes you would need to make to support that? You don't necessarily have to do it. Just kind of high level.
Yeah, so you need to have for each user, for each run, what we want to do is we want to store the like some test run ID, and then you want to have a test case ID, and then you want to have, or sorry, what you want to have is two things. Is one is the test run ID, whether it passed failed, and then you also kind of want to have a separate section, in my mind, where you're including information about each of the individual tests. But the more I'm thinking about that, I think the more it depends on product, right? What kind of granularity you care about for displaying to the user, and whether we care about looking back on this data in the future.
Makes sense. Cool. I just wanted to see what you thought about that. I think maybe what would be more interesting now would be to talk about data. So you said you prefer this to using Delta containers, right?
Mm-hmm.
Are there any other limitations of using Lambda besides cold start? Let's assume cold start isn't a problem, right?
Yeah. Nowadays, cold starts isn't really a problem, but you also do have timeouts. But it's something like 30 seconds. So again, we're not really gonna run into that issue, right? Is it 30 or 10? Either way, whichever one we pick, I think AWS Lambdas can fits for all of our constraints. Simultaneously, you can also set memory limits for your Lambda functions, and even for the default timeouts, you should be able to set a timeout that's even lower, right? If you want. So when we say that our test should execute within 5 seconds, maybe that's a constraint on the problem, right? Where universally we want all of our tests to run under 5, even though Lambda supports 10 to 30. So, all of this makes me say that, running on AWS Lambda works out well for us, right?
How about languages? Do they support any language you want? Is there a limited set?
Yeah, I definitely, for all of the popular languages, it should definitely allow you the ability to execute those, right? In terms of the details of how it's run, I'm actually not too sure. Versus, with the Docker containers, I know that you can have, these separate Docker containers that include all of the relevant environments. So if I were to think about how it works in Lambda, what it really is that these are separate Docker containers that AWS is abstracting away for us, right? So under the hood, it is just these Docker containers that have like a Go runtime environment or a Java runtime environment. And we just specify that, it's this language we want, right? If that makes sense.
Yeah, that makes sense. Cool. So I think your design covers a lot of functional requirements here. Do you mind just walking me through the end-to-end flow one more time? And then I have a couple of follow-up questions.
Yeah. So what we said is first we want to be able to view problems on a page. We're just gonna go to our single DB, get that info. The stuff about the user being able to edit their code live in an editor, we said that that's kind of all handled in the client, and there's some open source packages that allow you to handle that easily. The third one was we talked about users being able to execute code in a live sandbox environment. We chose to use AWS Lambda, where what we're going to do is, we submit. So over here, the user has the option to also submit, and that's going to pull our set of test cases for problem ID. Given our code, it'll run inside of AWS Lambda, and then it'll store for the user, some site submissions, submission ID, user ID, and then, pass fail, right? Because we don't care about more granularity. And then we kind of covered our non-functional requirements, not through maybe solving a separate part, but maybe just talking through what Lambda gives us as guarantees. I think one of the parts we didn't really cover is the scale that we're going to be operating at for this. If you want, I can cover that part now.
Yeah, please do. That was going to be the next question. So.
Yeah. So I think realistically, so originally I had this set up where we kind of assumed that this isn't going to be really heavy scale. And I think realistically, that is what we want to do. Because LeetCode in itself, let's say it has something like, we'll be really generous here. We'll say it has 5 million daily active users, which I think is maybe on the high end anyways, right? You can say that you have maybe 20 submissions per day per user. What does that translate into? That translates into 1K RPS? No, that's even lower than that. It's like 100, isn't it? Because we can assume that I'm bad at math. So 5 times 20 is 100. So yeah, 1K RPS was actually on the ball, because we can assume it's like something like 100K seconds per day. This is, definitely low enough scale that you can have all of this running on a single, a low number of servers, basically one. You can have basically 1 DB, and then the Lambda is, infinitely scalable, right? In theory. The only thing that might be relevant here is LeetCode actually has users from around the world, right? So if we decide that every user needs to go to US East 1, that could be expensive. And now the thing we have to think about is, does our latency requirements, is that actually a problem given our latency requirements? So for a lot of other applications, what you'll have to do is, if you want this to be available, globally, you're forced into, let's say this entire thing is running in AWS, you're required to make complete copies. You don't necessarily need to partition. You have to make complete copies of your system into completely far away DCs. I think that's not going to be required for us. I can talk a bit. So the reason I'm saying it's not required for us is because the stuff like the getting the problems, that stuff we can, that stuff we can actually put inside of a cache, a CDN, and all of that info can be stored, can be served globally, right, to users. But the actual test case running itself, which is the thing that we care about potentially having to replicate to multiple DCs, it doesn't matter if we take even 1 second longer, realistically, because we have that buffer. I can talk about what might happen if we do need to replicate, but if you want me to go into that, but yeah, I'm gonna leave it at that.
No, I think that makes sense. Yeah. I have a couple questions about your scale estimations here, actually. So this is presuming like an even distribution of submissions, isn't it?
Yeah. Okay, that is a fair point. So if I were to apply like a 2 to 3x buffer or multiplier, then that gives us something like 3K RPS, right? And I think, even at that scale, our... okay, so... if we did have this multiplier, the things I was saying earlier would still hold. The only thing we have to care about maybe is, what happens if somebody starts spamming, right? I wouldn't say that we would want to change the architecture of our system here, because these RPSs should be related to, global use, right? Not necessarily one spammy user. I think that is more that you would want some kind of rate limiting in the process.
Sure, that makes sense. Like you're saying, we'll have a rate limiter and that'll here. That's totally fine. What if I say during a contest it's more than a 2 to 3x multiplier? What if I said it was like 20x? There's a contest, we're giving a prize out. Everybody wants to win, right? So what if I said it's 20 to 30x? How would you deal with it? You don't have to change your design, just put it up through it.
Oh, you're saying what if it's like 20 to 30k RPS?
Yeah, exactly. For like a contest.
Okay, sure. Yeah, so I think if you do end up having a contest, for the most part, our decision to use Postgres should still work out. The question is are we actually getting any benefit from using Postgres compared to another DB? Because we don't really need to maintain referential integrity between our submissions. They're more like for Postgres, the nice thing is that when I say we don't need referential integrity, I mean there's no like concurrency issues for the most part. There's no isolation guarantees we need, all of the stuff for ACID compliance. The only thing that we're really getting is simplicity, in the sense that you can make simple relations between things like user IDs, test IDs, problem IDs. With multiple DBs, you no longer have that. So going back, Postgres, I would still stick to it. And I think we have some options for partitioning, right? So that all of the data for, let's say, test cases, you can split up, right? It's a bit weird because this info, like the problem info, I don't think we'll ever need to shard it because it's so limited, and we're mainly reading from CDN anyways. It's only this test info that really it comes up a lot. So the main thing I would think is not even partitioning. I think introducing a cache in between here is a better solution, so that even if we are hammering for reads, it's fine. Does that make sense?
Yeah, I think so. And we're kind of assuming problems change very infrequently here, right? So yeah, that totally makes sense. How about this part? Is this still going to work? Spinning up the Lambda kind of synchronously returning results to the client?
Yeah, I'm pretty sure that should be handled for us. It's like similar to if we need to upload a bunch of things to S3, right? It's I think the issues of scale is deferred to AWS.
Okay, makes sense. A couple of questions again, just high level. Don't need to write the whole design out. We talked about search and problem here, right? How would you approach it?
Right. So it kind of depends on what kind of search you want, right? When we say search, are we just going to do categories, or are we also including like title searches, or are we including searches on the problem statements? Like that's the first question.
What do you think is interesting?
I'm sorry?
What do you think?
Yeah, in my mind, the only thing that's really relevant is categories, because I don't think, I don't think people normally search for titles. Maybe I'm wrong on that, because what I think I usually end up doing if I do need to search is like maybe you copy into Google, right? If you wanted to have, I can talk about how we can solve for both, right? So for the categories, it's pretty straightforward in the sense that you just have, because it's limited in scope, you can have an index on something like a category. But then there's also tags, right? Which is the many, the one-to-many. So for that, you might be forced into doing a completely separate categories table, which has a category and then a problem ID, just because we're using SQL, and searching through that's going to be fine. Titles is the part that is more interesting because, if it's just prefix search, then sure, like it'll work fine. You can use a gin index on the title and give that back to the user. But I don't think that's the normal default pattern for how people look up. I think usually you want fuzzy search. And so what Postgres has is has an extension called pgtrgm, which lets you create trigrams on the title or even on the the description. Right? We can make an index on that for either one. And so then we have support for fuzzy searches. And because of the scale of our DB, such a tiny, like with pgtrgm, we can still support up to millions of problems. So with our maybe 5K problems, it's definitely within the constraints, right, of what this extension can do.
Cool, that makes sense. I guess we're kind of nearing time. Is there anything else you wanted to cover with your design here? Anything else you wanted to add, or?
Yeah, I think for the stuff that we talked about, I think this is basically going to be it. We did kind of list the running competitions as second prio, but I think we more went into the other parts, right?
Yeah. If you want, like, take 5 minutes and maybe walk through what you're thinking for running competitions, but you don't have to design it.
Sure. Yeah, I can list, some of the tech that I'm pretty sure we're going to have to run. So, for running competitions, I know something that people often do for leaderboards is that, they're going to go ahead and have some kind of sorted set in Redis, right? But that's kind of assuming that there is leaderboard. And I feel like if I had 5 minutes, I most of it would be actually questions about what a running competition means, right? In my mind, it's you have a time-bounded, just on the user end, not the admin end, you have a time-bounded problem, and you have people who are all registered to do these problems over the course of maybe 2 hours. And then as users are submitting, they're going to get a score based on which set of problems they've done, right? So all of our existing infra would work to do the code execution stuff. And I think the main addition is that as problems are, added in, you would have your, contest ID going to maybe, your sorted Z set, right? In Redis. But that seems like a bit too hand wavy. Like I feel like there's like more details to iron out there. But that's like how I would say it is at the high level, right?
Yeah, I think that's fine. Okay, cool. I think like this would kind of be the end. If you want, I have a couple follow-up questions. It's just interesting for you to kind of work through them. Do you want to do that, or are you kind of?
It's up to you. Like, I mean, it's definitely helpful for me to do the follow-ups, but I don't know
Sure.
how you wanted to set it for, feedback time versus like sticking to the 35 minutes, right?
Yeah. I have some notes on the side here. Why don't I ask like one question? Maybe it might be interesting.
Sure.
So I know I kind of told you like don't write it out, but what we're doing here is we're submitting a problem, running it on Lambda, returning it to the client, and then we're also writing it to a submissions table here, right?
Mm-hmm.
And this is kind of what it looks like. What happens if I start the Lambda up, it's running, and then my node goes down?
And the node goes down. Okay. Yeah, I can talk a bit about how that would work. So, if that's the case, the node going down means that it's basically like a complete invisible failure that no part of our system knows about. I imagine the default for handling something like that is actually forcing all of your items to go through a queue, right? So when I say queue, I mean specifically Amazon SQS, because what you can do with SQS is set some kind of no, this seems overkill. Let me think about this. What I was going to suggest is that with SQS, every single time your Lambda function, picks up an item, what you do is you can take items from the queue and change their visibility timer, right? So that no other separate worker can pick it up. But and then once you finish the job, you actually mark the job as complete. I'm thinking if that's really the best way to do this, or if there's something simpler, because we're introducing a queue, right? That's like an additional operational complexity, in a sense. So I will say that this is a solution, but let me think if there's a simpler solution. And I'm thinking there might not be, because even if a test dies, the client has no way, unless what we say for failure is that after some separate client-side timeout, we would mark to the client that there was some unknown issue. So for simplicity, I think I would lean on the second option that I listed here, which is that you would have a separate client-side timeout to indicate that something went wrong in the system and the client just has to rerun, because these should be rare. And if we really wanted, complete resiliency, then SQS is the option, but I think it's over-engineering for the problem given.
Nice. Okay, cool. Yeah, I think that was it in terms of follow-up questions. Yeah, awesome. What do you think?
Yeah, I thought this was interesting. So I do know about the whole being able to run on AWS for remote code execution, but yeah, I think the follow-ups were definitely useful to kind of think on the spot.
Sure. Yeah, maybe I can give my feedback too. So I timed everything. I think functional requirements you finished in 4 minutes, and that's like inclusive of you asking questions. Then non-functional was about 6 to 7. So yeah, I think timing-wise things are perfect. The API was about 5 minutes. Like overall, I like your presentation style. I feel like you talk through things pretty well. It doesn't come off as like rehearsed, which I've noticed with other mock interviews I've done. Like people kind of feel like they're reading a script. I feel like you're really kind of talking it through, which is great. Good confidence. The overall flow, I think you're using like the hello interview kind of flow, right? And I think it works pretty well. Let's see, other positives. Yeah, I think you went through trade-offs, which is good, instead of just like picking something, like for example, Lambda versus Docker here. I think some of the tech things are cool too. Like when you talked about the trigrams, you talked about client-side like sandboxing. I thought those are interesting and like nice little flair, I guess. And by the way, I'm sorry, I realized I dropped my mic like in the beginning, so it was hard to hear me. I'm sorry about that.
Okay, no, I didn't. I could still hear you.
Okay, cool. So I do have like some nits and stuff like that, and like maybe some feedback. I think, like I thought about pushing on this, but I think this requirement maybe boxed you in a little bit, like tested execute in under 5 seconds. Like one follow-up I was thinking of making is like, sometimes you want to test time complexity, right? So if you want to run with a very large output, is this going to hold? I mean, maybe you'd be able to defend that, but that's just the follow-up that I had. So something to think about. Let's see here. I think this API should be paginated, like not a big deal, but, oh wait. Oh, you didn't even have the list. Yeah. Sorry, I meant to say like we should have the paging list thing, but sorry, the list API. I'm tripping over my words. Yeah. So I think that would have been useful to have here, maybe. But I think it was fine. Again, it's a nit. So I think the major thing for me though was like you had this synchronous flow, which I actually wasn't expecting. I thought it was quite interesting that you chose to do it. Like, I think if you wanted to do this, it might have been helpful. Like I know usually with like especially the hello interview format, they don't recommend doing the back of the envelope calculations. But I think it might have been helpful to do this earlier, just to say like, this is the reason why I don't need like a message queue or, set of workers. It's like one thing I was kind of getting at is I don't know, does Lambda have quotas where you can't spin up like 30K Lambdas a second? I would assume so. Like I'm familiar with Azure functions and you definitely can't. So
I'm actually not too sure. I don't see why you couldn't spin up a ton of lambdas. Like I could understand if there's a limit on a maybe per server basis, but if you have more servers, don't they just let you pay to get more?
So I'm more familiar with Azure. Like there's quotas on pretty much everything in terms of like how many resources you can spin up. Like I think some things are like pretty infinitely scalable, like blob storage, for example, like I think you mentioned. Usually I think compute has some bounds though. Like maybe we should check afterwards, but I would just be a little careful. Like if you're gonna pick that, like make sure you know for sure. I'll look it up later too, just to let you know. But
sure. Yeah. I think on my end, the thing that I didn't like is maybe sometimes it felt like I was just kind of yapping. There's a positive in the sense that you do talk through the trade-offs. Like for example, when we talked about the using SQS versus just having a client-side timeout, right? That could be maybe interesting, but I think maybe if I take it too far, then you kind of lose the focus, right, in the question, and it didn't become an issue in this problem, I think, as much because it's a bit more limited in scope. But other problems, I could definitely see this, becoming an issue. And then I don't know how you felt about the part where, I kind of got the sense that at the later stages, it was less me driving the conversation and more you doing follow-ups. I don't know if that would be negative. Yeah.
I didn't think so. I mean, I'll be honest, like I thought you got through the design pretty fast and pretty confidently, so I thought it might be interesting just to have follow-ups. And I think what I've heard, and I mean, I guess the way I do interviews usually too is like maybe you're just probing for depth kind of too, right? I guess like because like you said, there's so many different directions you can go here. I think it's just sometimes whatever the interviewer is interested in. I don't think it came off negative for me at least though, because
got it.
Oh, one other positive, like yeah, I was kind of on the fence like about this Lambda approach, but when you said client-side timeout, I was like, okay, maybe this is pretty sophisticated because like you're choosing to do this synchronously to save on complexity, right? And you're talking about like why I don't want to introduce a queue. I think this is kind of the answer I was looking for actually. It's like the client, like personally, like I'm not going to worry about a node going down because the client will just retry. I think that's perfectly sensible. Like, and I think it kind of tied your design together really well. So that was cool. Like, actually, that was a positive signal for me. Like that you were able to come to that conclusion. If you had done this queue, I would have said like, oh, you picked a synchronous API, but you're not really like doing anything with it. You're not getting any advantage from it, and that would have been like negative. So does that make sense? Like,
Yep, that makes sense.
And then, yeah, I think, honestly, one thing I should apologize for, like, the test run history, I meant to not ask about that. I just kind of forgot about that in my notes. Like, I have a list of requirements on the side here that I was going to ask about, so that was just a miss on my part. Sorry about that. But
it's totally fine.
yeah, I think that's all of my feedback. The major thing I would just say is like, yeah, if you're going to use Lambda, be sure. Like maybe you're right and maybe I'm just tripping right now, but